Problem 3, we have another calculation problem. It says, two brothers threw marbles off the top of the Mamba roller coaster. Part A, the older brother threw his marble straight down with a velocity of 6 meters per second. He counted, very precisely, and the rock took exactly 3 seconds to hit the ground. How tall is the roller coaster? Just FYI, this is the actual height. I used the actual height when I found this. So, start with what you know. What is given in the problem? So, they told us the velocity that he threw the rock with was 6 meters per second. Okay? So, usually our velocity initial is 0 because it's usually something that's just dropped. In this case, it was thrown. So our VI in the vertical direction is 6 meters per second downward. So we have to have a negative as our initial velocity. He counted and the rock took exactly 3 seconds, so our delta t for this problem is going to be 3. And the Mamba is here in Kansas City, so we know it's on Earth. Gravity is negative 9.8 for this problem. Meters per second squared. Great. So now they're asking how tall is this roller coaster. Using these, we can find out delta y. So we're thinking about a vertical height here. We're looking at our vertical motion. And equation number 2 gives us an equation for delta y. So delta y is going to equal our velocity initial, which was negative 6, multiplied by the time, which was 3, plus 1/2 the acceleration of negative 9.8 multiplied by the time squared. So once again, that 3 seconds, but we have to square that. Don't forget the square. Everyone always forgets that. Okay, so when you're solving this problem, you have to square that 3 first. So delta y will equal the negative 6 times 3 will give us negative 18 on this side. Multiply that together, plus 1/2 of negative 9.8 will give you negative 4.9 times the 3 squared, which gives you 9. Okay, that makes delta y equal to negative 18 plus negative 4.9 times 9. Let me get a calculator really quick. That gives you an answer of negative 44.1. The last step is just to add those together. So you have a negative, and you're adding another negative. Your final answer will be negative 62.1. So a lot of people got this answer, and they said, why is my height negative? Well, if you remember, you're starting from a height of 0, and it's dropping down from there. So you should end up with a negative for your delta y. So 62.1 meters, that's the height of the Mamba. Okay, part B, the younger brother dropped his marble from that exact same height. How much longer did it take this marble to hit the ground? So remember back to the first problem, this guy threw his marble down at 6 meters per second. The other brother, he did not throw his at all, he just dropped it. So in this problem, your velocity initial is not that negative 6. Your velocity initial is 0. Your height is what we just found it to be. It's that 62.1. And once again, your acceleration is due to gravity, so it's going to be that negative 9.8 squared. They're asking how much longer did it take. So we need to find out how much time it took the one that was dropped to fall. Well, since our velocity initial is 0, check out that little note. We can use the square root equation that we use a whole lot. delta t is equal to the square root of twice your height divided by the acceleration. So plugging those things in, delta t is equal to the square root of 2 times the height of negative 62.1 divided by our acceleration of gravity, negative 9.8. So you multiply and divide everything within the square root, and then you hit the square root button last. So 2 times 62.1 divided by 9.8, and then you hit your square root button. Make sure you can do that in your calculator. You should get a time of 3.559, so 3.56 is what we'll round that to, seconds. Great, so the brother that threw the marble, it only took 3 seconds. The brother that dropped the marble, it took 3.56. The question really did ask how much longer did it take, so if you want to be completely accurate with this, you should say that it took 0.56 seconds longer than the first brother. And that's number 3.